All right, problem number 3. A biologist is researching a newly discovered species of bacteria. At time t equals 0 hours, he puts 100 bacteria into what he has determined to be a favorable growth medium. Right? 6 hours later, he measures 450 bacteria. Assuming exponential growth, key phrase there, exponential growth, what is the growth constant K? This is what we're going to be looking for the bacteria. Well, there's only one formula that has a K involved, and that's the exponential growth, exponential decay model, which is y equals NE to the KT. So we're going to have y equals N equals. Keep in mind E is a number, not a variable, sorry. K equals T equals, all right? And we're looking for the growth constant, which means we must know the other 3 things. Now, Y is the ending number of bacteria, N is the starting number of bacteria, T is the amount of time in hours in this problem, okay? So he puts 100 bacteria into the favorable medium. So that's the starting number of bacteria, okay? 6 hours later, he measures 450 bacteria, okay? So now I have all of my numbers figured out, so I'm going to set up my equation. Y is 450 equals N, 100, E to the K times T is 6, right? So same as we did before, we have an exponential equation. We want to isolate the exponential part of it, so I'm going to divide out the constant out in front, all right? 4.5 is equal to E to the, I'm going to rearrange that and write it as 6K. Now again, because I have a base of E, I'm going to take the natural log of both sides instead of the common log, so that the E on the right-hand side can cancel off. So I'll get the natural log of 4.5 is equal to 6K. So then K is equal to the natural log of 4.5 divided by 6. Keep in mind there will be parentheses around the 4.5 when you type it in on the calculator. Now the natural log of 4.5 divided by 6 comes out to, if I go to 3 decimals, I've got 2506, so I'll make that 251, okay? Now if follow-up questions that could come after this, if this were like a part A, part B, I could say, okay, now determine the number of bacteria after 24 hours or a week later. And then we would be using the constant we just came up with to go from there. So my final answer in words is going to be the growth constant is. And I'm going to write 0.251, okay? This one isn't as meaningful as some of the other sentences that we've written, but it suffices to communicate what our final result was. Okay, so that was problem number 3. Let's take a look at problem number 4. All right, Sandy deposited $2,200 into a bank account. Okay, so we're talking about banking, so probably Formula 1 and Formula 2. If the account pays 3% interest compounded quarterly, key phrase there, compounded quarterly, not continuously, how much does Sandy have in the account after 5 years? So anytime we're not compounded continuously, we use the first formula, which is right here. So that's Formula 1. This is the longest formula. It has the most variables, A, P, R, N, and T, okay? Ending amount, starting amount, interest rate as a decimal, number of times you compound in a year, and then time. All right, so let's go back and read. So we deposited $2,200. So that's the starting balance is $2,200. Okay. The account pays 3% interest. Okay, so the rate is 3% or 0.03. Okay. Compounded quarterly means 4 times in a year because a year can be broken into 4 quarters, 3 months at a time. Okay. How much does Sandy have in the account after 5 years? After 5 years, T is 5 years. So we're just looking for the ending amount. And we love it when we're looking for the ending amount because it's just a matter of plugging it into a calculator. There's nothing for us to really solve. We just have to show what we told the calculator to do. So I'm plugging in the 2200 for P, 0.03 for R, N is 4, and then the exponent is 4 times 5, or 20, okay? Now, typing this into the calculator, you can do it exactly the way that I have written here. You want to practice typing these things into a calculator, but again, on a test, you can ask for help if you're not entirely sure how to type it in. I'm just double checking my computation here. I came up with 2554 point, and then it's 605, so I'm going to round that to 61, okay? So I can say that Sandy will have $2,554.61 after 5 years. Okay. And there's problem number 4. All right, and as promised, we're just going to do 2 per video, so I'll see you in the next video to do problem number 5.